In late 2018 and early 2019, the world watched in horror as two brand new Boeing 737 MAX aircraft, operated by Lion Air and Ethiopian Airlines, plunged from the sky within 5 months of each other. These were not isolated incidents, the similarities were chilling, prompting immediate global concern. The crashes claimed a total of 346 lives, leaving a trail of unanswered questions and profound grief. This unsettling pattern demanded an urgent and thorough investigation into what could cause such advanced machines to fail so catastrophically. The aviation industry, synonymous with safety, found itself facing an unprecedented crisis of confidence. For decades, Boeing stood as an undisputed titan of the skies, an icon of American engineering prowess. Their 737 series, first introduced in 1967, became the best-selling commercial aircraft in history, renowned for its reliability and versatility. Airlines trusted Boeing, and passengers flew with confidence. This long-standing reputation was built on rigorous safety standards and continuous innovation. The company's engineering might was legendary, crafting planes that spanned continents and connected cultures. The idea that a new Boeing aircraft could be at the heart of such twin catastrophes was, for many, simply unfathomable given this illustrious history. The 737 MAX was Boeing's answer to fierce competition from rival Airbus and its highly successful A320neo. The MAX promised greater fuel efficiency, longer range, and a commonality with existing 737 models, appealing to airlines keen on minimizing pilot training costs. To achieve these improvements, Boeing fitted the MAX with larger, more fuel-efficient engines, positioning them further forward on the wing. This seemingly minor design change, however, introduced a significant aerodynamic challenge, altering the aircraft's pitch characteristics in certain flight conditions. This was the first domino in a tragic chain of events that would soon unfold. To counteract the altered aerodynamics of the larger engines, Boeing developed a new flight control system, the Maneuvering Characteristics Augmentation System, or MCAS. This software was designed to automatically push the aircraft's nose down under specific high angle of attack conditions, preventing a stall. It was intended to make the MAX handle like previous 737 models, ensuring it met certification requirements without extensive pilot retraining. Critically, the MCAS system on the 737 MAX relied on input from a single angle of attack (AOA) sensor. This reliance on a lone data point would prove to be a fatal design choice, a vulnerability waiting to be exploited. While MCAS was intended to be a benign, background system, its implementation on the 737 MAX had an unforeseen aggressive potential. If a single AOA sensor malfunctioned and sent erroneous data, MCAS could repeatedly force the aircraft's nose down, making it extremely difficult for pilots to regain control. This critical detail, the system's ability to act aggressively based on faulty data and its single point of failure, was largely undisclosed to pilots. Many pilots were unaware of MCAS's existence, let alone its potential to override manual inputs and command the plane into a dive. This lack of awareness set the stage for disaster. On October 29, 2018, Lion Air Flight 610, a brand new 737 MAX 8, departed Jakarta. Shortly after takeoff, the crew began to experience difficulties. The aircraft's angle of attack sensor was faulty, feeding incorrect data to the MCAS. The system repeatedly commanded the nose down, despite the pilot's efforts to pull up. A desperate struggle ensued in the cockpit, with pilots fighting against an automated system they didn't fully understand. Just 13 minutes into its flight, the plane plunged into the Java Sea, killing all 189 people on board. It was a tragedy that would shock the world and mark the beginning of intense scrutiny on the 737 MAX. In the immediate aftermath of the Lion Air crash, investigations began. While a faulty AOA sensor was identified as a contributor, the full extent of MCAS's role and its potential danger was not yet widely understood, nor publicly disclosed by Boeing. Regulators, including the FAA, issued advisories but did not ground the fleet. There was a prevailing belief that pilots could counteract the system's inputs if properly trained. However, the critical flaw lay deeper: the system's aggressive nature and the lack of comprehensive information for pilots. The regulatory framework that allowed this system to be certified without broader pilot awareness would soon come under severe scrutiny. Just over 4 months later, on March 10, 2019, history tragically repeated itself. Ethiopian Airlines Flight 302, another 737 MAX 8, crashed 6 minutes after taking off from Addis Ababa, killing all 157 passengers and crew. The flight profile was eerily similar to Lion Air 610, erratic climb and descent, followed by a sudden, uncontrollable dive. Investigators quickly recognized the horrifying parallels. Again, a faulty angle of attack sensor had triggered MCAS, forcing the nose down against the pilot's desperate attempts to save the aircraft. This second disaster proved beyond doubt that the problem was not isolated, but systemic. The second crash triggered an immediate and unprecedented global response. Countries around the world, one by one, began to ground their 737 MAX fleets, defying initial hesitations from the FAA. China was among the first, quickly followed by the European Union, India, Australia, and eventually, even the United States. This cascade of groundings, an extraordinary measure in aviation history, highlighted the profound loss of trust in Boeing and the 737 MAX. The sight of hundreds of new, expensive aircraft sitting idle on airport tarmacs became a stark symbol of a crisis engulfing one of the world's most prominent aerospace companies. Investigations into the crashes revealed layers of systemic issues, beginning with the immense pressure Boeing faced to compete with Airbus. The A320neo was gaining market share rapidly, and Boeing needed a quick, cost-effective response. Rather than developing an entirely new aircraft, they opted for an updated 737, the MAX. This decision was driven by the desire to maintain commonality with previous 737 models, thereby reducing pilot retraining requirements, a major selling point for airlines. This economic imperative, while understandable from a business perspective, arguably influenced design decisions and risk assessments, prioritizing speed to market over exhaustive safety checks. Another critical revelation was the shortcomings in the regulatory oversight process. The Federal Aviation Administration, FAA, traditionally considered the gold standard in aviation safety, had delegated significant portions of the 737 MAX certification process to Boeing itself. This organization designation authorization program, meant to streamline certification, meant Boeing employees were, in effect, signing off on their own company's work. This approach, intended to leverage industry expertise, created a potential conflict of interest and raised serious questions about the independence and thoroughness of the safety reviews, particularly regarding new, complex software systems like MCAS. Perhaps one of the most damning findings was the insufficient information and training provided to pilots regarding MCAS. Boeing had intentionally downplayed the system's complexity and potential impact, fearing that extensive new training would deter airlines. Pilots were simply not informed that MCAS existed, let alone how to respond if it malfunctioned. This omission meant that when the system erroneously commanded the nose down, pilots were caught completely off guard, struggling to interpret unfamiliar warnings and override a system designed to be largely invisible. The difference between a minor incident and a catastrophic crash often comes down to pilot knowledge and response, which was tragically absent here. The flight data recorders, FDR, and cockpit voice recorders, CVR, from both crashed aircraft provided crucial, harrowing insights. They painted a clear picture of the final moments, pilots frantically trying to understand and counter the automated nose-down commands. The data showed the AOA sensor feeding faulty information, MCAS activating repeatedly, and the pilots' desperate struggle against a system they weren't equipped to fight. This digital evidence removed all doubt, conclusively linking MCAS to both tragedies and exposing the fatal flaw that Boeing had introduced into its latest and most advanced iteration of the venerable 737. In response to the catastrophic failures and the global grounding, Boeing embarked on a comprehensive software update for the MCAS system. The revised software now takes input from both AOA sensors, not just one, and activates only once per event, preventing repeated nose-down commands. Furthermore, it limits the system's authority to ensure pilots can always override its inputs. These changes were critical to addressing the direct cause of the crashes. This extensive overhaul required meticulous testing and recertification by aviation authorities worldwide, a lengthy and costly process but absolutely essential for the aircraft to ever fly again safely. The journey to recertification was arduous and thorough. Regulators in numerous countries conducted independent safety reviews, ensuring the updated MCAS software and revised pilot training protocols met the highest standards. It took nearly 2 years, billions of dollars, and unprecedented scrutiny before the 737 MAX was finally cleared to return to service, starting with the FAA in November 2020. This rigorous process aimed to restore public confidence and ensure such a tragedy could never recur. While the aircraft is now deemed safe, the shadow of the crashes continues to impact its public perception and Boeing's reputation. The crashes led to a profound reckoning for Boeing. The company faced multiple lawsuits, congressional investigations, and a monumental financial hit, estimated to be over $20 billion. Its long-standing reputation for engineering excellence was severely tarnished, and its relationship with regulators became strained. The incident served as a stark reminder that even the most established and trusted companies can falter under pressure, and that safety must always remain paramount, never compromised for the sake of speed or cost. The company vowed to implement cultural changes, emphasizing transparency and a renewed focus on safety above all else. The 737 MAX crashes became a painful but crucial lesson for the entire aviation industry. They underscored the dangers of over-reliance on automated systems without adequate pilot awareness and training. They highlighted the need for robust, independent regulatory oversight that resists industry pressure. The incidents also sparked a global re-evaluation of how new aircraft are certified, pushing for greater transparency and international collaboration in safety standards. The core takeaway is clear: while technology advances, human factors, both in design and operation, remain at the heart of aviation safety, demanding constant vigilance and respect. Today, the 737 MAX is flying again, updated and recertified, with enhanced pilot training and a re-engineered MCAS. But the scars remain. The crashes forever changed how the world views aviation safety, prompting a deeper look into the intricate relationship between manufacturers, regulators, and airlines. The real reason Boeing's new plane crashed twice wasn't a single flaw, but a confluence of design compromises, regulatory lapses, and a failure to adequately inform and train pilots. The hope now is that these tragedies serve as an enduring reminder: the pursuit of innovation must always be tempered by an unwavering commitment to the safety of every soul in the sky.